right, we are looking at using formulas and units to solve problems. So this is lesson 1.2 for coordinate algebra. The first problem we're going to take a look at is to use the formula for Ohm's law to solve for currents, volts, and resistance. So we're going to take a look at being given a problem and being given the formula and then solving based on the information given. So we're told an electrical current or electrical circuit at a current of 1.2 amps and a voltage of 10 volts. So we're asked, what is the resistance in the circuit? So Ohm's law is given with the equation. We're given I equals V over R, and we're told where I equals the current or the amps. Now we're given that current, that amps, so we can already define that variable, I equals 1.5. And we're given V equals voltage in volts, and we're given our voltage of 10 volts. So I can define that, V equals 10. And we're asked what is the resistance, and we're told here that R equals the resistance in ohms. So that's the variable we're finding. We're finding what R is. Now our formula is given us in terms of I. So we're told I equals V over R. So we're going to reset this formula so that it's R equals. So we have I equals V over R. So first thing I want to do is multiply both sides by R. And on my right side, the R's divide out. So I'm left with Ri equals V. And once again, I want to isolate the variable R since that's the variable I'm trying to solve for. So divide both sides by I. The I's here divide out. So we're told the resistance equals the voltage over the current. And now we have a formula we're going to substitute in. So R equals V, which we already defined here as 10, over I, which we have found here to be, or given as 1.5. Now, since we're looking at a real-world situation, we do want to approximate, so we'll be using our calculator here. So 10 divided by 1.5 is approximately 6.67. And since we're given our units, we want to make sure we include that is 6.7 ohms. And just for your reference, the symbol omega equals ohms. So we're going to say the resistance is 6.67 ohms. And that is our answer for the first problem. Now the second one is going to be a similar type of problem. So we're going to take a look at the same formula. All right, so for this one, we're told an electrical current has 3 volts and a resistance of 9 ohms. So what is the current of the circuit? Now going back with the formula we were given in the previous slide, we're told I equals V over R. Now in this case, we're given 3 volts, so we can define V equals 3 and the resistance of 9 ohms. Now that resistance is the R variable, so R equals 9. So the current, and the only variable we don't have a numeric value for, is I. So that's the variable we're trying to find. So we have our 3 identifiers, so we can substitute to find for I. Now our original formula is given in terms of the variable we're trying to find, so we don't need to reformat that equation. So I equals 3 over 9, which simplifies down to 1/3. But once again, let's approximate since we're talking about current here. So we're going to approximate that to be 0.33, and we want to include units. Now if you forget what unit it is, you can just look back to the last slide, and that's in amps. So the current of the circuit is 0.33 amps. All right, now let's look at a problem where we're not given the formula. We're going to have to create that one. And we're told for this one, a businesswoman is reimbursed $50 a day for food and lodging. She also receives 55 cents for each mile driven. Now we're told she drives 384 miles and is reimbursed $361.20. How many days was the trip? Now, in order to do that, we're first going to define variables. Now, I tend to lean towards using x and y, but you can use some different variables there if you want to. So I'm going to define x based off this first part, $50 a day. So x I'm going to define as the number of days on the trip. And y I'm going to define in terms of that second bit, 55 cents for each mile driven, as the number of miles driven. Now the whole point in defining variables, especially at the beginning before you write an equation, is so when you get your answer, you can interpret what that means in relation to the problem. So our formula here, she gets $50 per day driven, so 50 times x, the number of days on the trip, plus the number of miles driven times 0.55, and the number of miles driven we defined as y, is going to equal the total amount that she's reimbursed. Now here we're given a few things. We're asked how many days is the trip. So x is a variable we're going to be solving for, and we're told that she drives 384 miles. So y equals 384 miles. So we're going to substitute 384 for y. So our next step would get 50x plus 0.55 times 384. Now we're told her total amount reimbursed is $361.20. So we're going to put 361.20. And now we have a one-step linear equation to solve for. So we have 50x plus, multiply that out, and we get 211.2 equals 361.20. Subtract 211.2 from both sides. That cancels out. So we're left with 50x equals 150. And to solve for x, since we're multiplying, we're going to divide our inverse property. The 50s divide out, so we're left x equals 3. Now, we're told x equals 3, but since it's a word problem, we want to express our answer in words. So it's how many days was the trip? X equals 3 doesn't tell us how many days was the trip. We need to express that. So the trip was 3 days, which makes sense that it is a whole number, since she gets reimbursed $50 a day and she was gone for 3 days. So our answer makes sense in terms of the problem. All right, we're going to take a look at our next problem, and that's converting with a unit factor. Now here we're going to convert on the metric scale. So we're going to go from one part of the metric scale to the other. Now, the exact unit of measurements, if we're looking at weight, volume, distance, is going to change, but we can use the same conversion scale. Now I use the saying, King Henry died by drinking chocolate milk. And that B is your base. So it's your meters, liters, depending on which unit or what part or classification measurement you're looking at. So for this first problem, we're going from 3.5 kilometers, and we want to know how many millimeters that is. So King Henry died by drinking chocolate milk. So we're starting at kilometers, and we're going to end at millimeters. So we're going from here to here. Put a decimal after the letter, and you count how many times you need to go over. Now here we're going to the right, and we're moving that decimal to the right 1, 2, 3, 4, 5, 6 times. So we have 3.5, and that decimal will move to the right 1, 2, 3, 4, 5, 6 times. So 1, 2, 3, 4, 5, 6. So again, put a dot. We want it to be the right, decimals to the right. And at each indentation, I'm going to represent a 0 with that. So that's 3,500,000 millimeters is 3.5 kilometers. Now I'm going to use the same conversion scale. King Henry died by drinking chocolate milk. This time I'm going from milliliters to liters, which is the base. And this time I'm moving my decimal to the left 1, 2, 3 times. So 54.6, with that decimal to the left, 1, 2, 3 times. So 54.6 milliliters is 0.0546 liters. And when you have a decimal that's less than 1, it's proper notation to put a 0 to the left of that decimal as an indicator of a place value. So that's how we'll be converting when on the metric system. All right, let's take a look at conversion in between different systems. So first we're told if you were going 50 miles per hour, how many feet per second, it should be second, how many feet per second, or I guess that works, how many feet per second are you traveling? And I went ahead and gave you have 5,280 feet in a mile. So here I'm going to set it up. We have 50 miles per hour. Now the top unit's incorrect, as is the bottom unit. So we're going to expand that out, and I'm first going to convert 50 miles. Now I'm told in 1 mile we have 5,280 feet. Now the whole purpose of putting the mile, that ratio, the mile at the bottom, is so that these miles divide out. And now I have it in terms of feet. Now my denominator needs to be in terms of seconds, and it's in hours. So I'm going to break that down. I know in 1 hour I have 60 minutes, so I'm going to divide out the hours. And then I know I have minutes here now, so I'm getting closer. In 1 minute there are 60 seconds, so I'm going to divide out the minutes. So now all my units are in terms of what I want. Feet is the only units left in the numerator, and seconds is their units left in the denominator. So I'm good to go. So I multiply my numerators together. So 50 times 5,280 times 1 times 1 is 264,000 feet. Once again, feet's the only unit here. And in my denominator, I have 1 times 60 times 60 seconds. So that will give me 3,600 seconds. Now I want to put this in per seconds. So I want to have 1 second in my denominator. So I'm going to be simplifying. Now here, and that's a comma, I can divide out 2 zeros automatically. And then 2,640 divided by 36 gives me 73 1/3. So I'm going to be 73 1/3 feet per second. So if you're going 50 miles per hour, how many feet per second are you traveling? You're traveling 73 1/3 feet per second. So that's our conversion there. Now 5B, we're asked how many seconds are in a day. Now this one we just have one conversion, but we're going to use the same setup as over here. We're going to be breaking this down. So I'm going to use, I know in 1 day there are 24 hours. So my days have divided out. Now I need to get rid of hours, so that's going to go down here. Now I know in 1 hour there are 60 minutes. So I divide out my hours. I need to divide out minutes because I want seconds. So I know in 1 minute there are 60 seconds. Now you may know more conversions, not have to break it down as much, but this is an always default way that you can figure out conversions. Write down everything that you know. So my denominator is just 1. All the units have divided out. 1 times 1 times 1 is 1. My numerator, I have 24 times 60 times 60, and that gives me 86,400. But once again, we want to make sure units. So there are 86,400 seconds in a day. And that is our answer. Hope you have a great evening, and I will see you tomorrow.